This video, I'm going to prove that phi of n is equal to n minus 1 if and only if n is prime. If you like seeing mathematical proofs or facts like I just stated, you should consider subscribing to my channel, as this is what we do on this channel. So I'm going to assume this is true. I'm going to assume that phi of n equals n minus 1. Assume. Well, what that means is you have 1, 2, 3 up to n. The only number, so there are n numbers. And clearly n goes into n. So these must be the n minus 1 numbers that have nothing in common with n. Okay, so let her say that. Consider the numbers 1, 2, 3 up to n. Clearly, the GCD of that last number with n is n. It's not 1. Okay. This implies that phi of n is less than or equal to n minus 1. Because maybe there are other numbers to cross out. Since phi of n is equal to n minus 1, that implies that 1, 2, 3 up to n minus 1 and n are relatively prime. That is, these numbers are not factors of n. That implies that n is prime. That implies that n is prime. Now we go the other way. Okay, I want to show, so this says if n is prime, then phi of n is equal to n minus 1. But I'm not going to do that. I'm going to negate this and negate that. That is, if phi of n is not n minus 1, then this is not true. Then n is not prime. Then n is not prime. And you don't need to write this in the proof, so I am putting it in these brackets, but that's what I'm starting. That's the way I'm gonna prove this piece. I'm gonna use the contrapositive. Okay, so assume phi of n is not equal to n minus 1. Well, phi of n can only be n minus 1 or less, because you only have up to n numbers that might be relatively prime with n. And it certainly isn't n. That is, phi of n is less than or equal to n minus 1. But if it's not n minus 1, that means phi of n is less than or equal to n minus 2. Okay, y, which is n minus 1 minus 1 or more. Why is phi of n less than n minus 1? That's because there must be a divisor of n. Let's call it d. There must be a divisor d of n where d is bigger than 1 and less than n. Okay, so that implies that n is not prime. N is not prime. And that's what I wanted to show. I'm not sure if I even know how to show this directly. I'm not even sure if I know how to do that. You do it by counter example, but using the contrapositive, in my opinion, worked out nicely. If you like seeing math proofs like this, you should consider subscribing to my channel. Please click the like button. See you guys in the next video. Don't forget, watch and learn.